In this video, we'll be doing 4 examples on the tangent substitution. And if you guys need help with the sine and secant versions, you guys can check out the links in the description. Okay, so the question is, when do we use tangent? And the answer for that is, pay attention to x squared plus a squared, or maybe the other way around because the order of the sum doesn't matter. And when we have that, go ahead and let x equal a times tangent theta, and you are going to expect to use tangent squared theta is plus 1 is equal to secant squared theta. So now let's take a look at the first one. We have the integral of 1 over a squared plus x squared. There's no square root, but it's okay. It's just that sometimes when you have the square root, this right here might be really useful, but if you don't have square roots, you can still use it, maybe, right? So let's go ahead and proceed and see what happens. Right here, let x equal a times tangent theta, and then we'll just do the usual business. So differentiate, we get dx equal a times the derivative of that, which is secant squared theta d theta. And now we can take this integral to the theta world. So here we have the integral, and we have 1 over a squared plus, here we have x, which is that, namely tangent theta with the a in front, and we will just have to square that. We are not done yet because the dx is this, so go ahead and put that down, a times secant squared theta d theta. Okay, now let's fix this part. Here we have a squared, here we also have a squared, so we can factor that out. Put that down here, and we are left with 1 plus tangent squared theta. This time there's no square root, we'll just keep working on this. You see, this right here is precisely secant squared theta. So let's write that down. And now here's the deal. As we can see, right here we have the secant squared theta on the bottom, and we also have the secant squared theta right here, so they can cancel out completely. But be really careful though. This is only a to the first power, but this is a squared on the bottom. So we can only cancel one of them out. So this right here will give us 1 over a. Let's just put that all the way in front of the integral, and then we have the integral, and the rest of the things cancelled already, so we just have 1 in the theta world. So this right here is going to give us 1 over a. The integral of 1 in the theta world is theta. So now, to figure out theta, we'll just go back here. We know x is equal to a times tangent theta, divide both sides by a. So we are looking at tangent theta that's equal to x over a. To get theta by itself, we just do the inverse on both sides. So theta is equal to inverse tangent of x over a. So we just put this right there. So finally, ladies and gentlemen, we will have 1 over a times inverse tangent of x over a for our answer. And of course, put on the plus c. This right here is it. And this is a standard result. You are going to remember this result right here, so that later on when you encounter this, especially when we do partial fractions with rational functions integrals, we'll be using this quite often. Okay, for number 2, we have the integral of 1 over x plus third power plus x. And you don't necessarily have to do trig sub for this, but since we are doing the trig sub video, so we will do trig sub. But the thing is that, you see, we have x to the third power plus x. That's not what we have right here, huh? So this is what we are going to do. Just factor out the x and see what happens. Integral 1 over, I will factor out the x, and we are looking at x squared plus 1 inside, and then we have the dx. From here, we can do trig sub. Here, the a is 1, so I will just go ahead and say x equal 1 times tangent theta, and then the usual business, dx is just going to be secant squared theta d theta. Okay, here is the integral. We have 1 over, here we have x, which is tangent theta, so let's put that down. And if you are comfortable enough, you see tangent square theta plus 1, you know you can just put down secant square. That's fine, but I want to do this work for you guys. So let me just rewrite it right here so you can see the substitution. here we have x, and that's tangent theta, but we have to raise that to the second power, and then plus 1. All right, so that's good. And then we have the dx, which is that, so let's put down secant square theta d theta. Okay, let's see. This is equal to secant square theta, so let's put that down. Well, we see that here we have secant square theta, and that's also secant square theta, so they happen to cancel each other out. Here we are looking at the integral, and we have 1 over tangent theta. It's just cotangent, and if you know the standard result, you can just go ahead and put on the answer. But let me just do that for you guys. 1 over tangent, it's the same as cotangent, which is cosine over sine. So I'm going to look at this right here and put down cosine theta over sine theta, and then we have the d theta here. Okay, so right here I can just do a u sub, let u equal sine theta, and then you see du equal to cosine theta d theta. So this is the regular u substitution, and we can take this to the u world. You see that this right here is precisely our du. So we are looking at the integral of 1 over sine is the u, and then this part is the du. So of course we just get ln absolute value of u, and u is sine theta, so we can just put that down. And again, as I said earlier, if you recognize we are integrating cotangent theta, you could have gone from here to here, but I just want to do the little proof for you guys, just in case if you need to see it. We're not done yet, because this is still in the theta world, so we have to go back, and to do so, we are going to look at this. So here, we know that tangent theta is equal to x, and we are going to purposely look at this as x over 1, so that we can draw our right triangle. Put the right angle here, and then the angle theta here. This time we have tangent, and that means we have to do opposite over adjacent. So it's like this. And now to figure out the hypotenuse, first you open the square root, and you do this thing square, and then you do that thing square. Yeah, just like that. So finally, what do we have? Sine theta is just opposite over hypotenuse, so all in all we can look at this as ln absolute value, and we have x over that over square root, and we have 1 square, which is 1, and then the x square. Yeah, just like this, and then we are done. Put the plus c. This is it. For number 3, we have the integral of square root of 1 plus x squared over x. So we see the a is equal to 1. Let's just get started. Let x equal tangent theta, and then dx is just secant square theta d theta. In fact, this is a hard one, and you will see why. So let's see. Here we have the integral, and I'm just going to put down square root, and we have 1 plus, and this is dx, which is tangent theta, and then we will have to square that, so I'll put the square right here, and then over another x, which is tangent theta, like this. And then for the dx, we have that, so we'll put down secant square theta d theta. Alright, so now perhaps we have done this enough already, so we can do a couple of them in our head. This right here is just secant square, but that's instead of the square root, so we just get secant theta, right? And we have another secant square theta. So altogether, it seems like we have secant to the 3rd power theta on the top. Right? Again, all this right here is just equal to secant theta. And then on the bottom, we have tangent theta. So that looks okay, right? Just multiply this and that, we get this, and then we have the tangent theta on the bottom. But the thing is that I think this right here, it's actually kind of hard to integrate. So you guys can let me know, maybe some of you guys would prefer to write everything in terms of sine and cosine. that might work, or maybe you have any kind of way to do it, you can let me know. But this is how I would like to do it. Notice here we have secant square theta. What I will do is we are going to actually look at this backwards, and you'll see why. So again, I am not going to continue right here because of the secant to the third power. I'm going to utilize this, and then I'm going to break it apart for you guys. So here's the deal. We have the integral. We have a secant theta on the top, so let's put that down. And then over, this is tangent theta on the bottom, so no big deal. But for this part, I will rewrite this as tangent square theta plus 1. And we are in the theta world, like so. Why do we do it? Because this way, I'm going to just pair them up together, and you'll see they simplify pretty nicely. Have a look. Right here, I'm just going to write it down right here. We have the integral. This is secant theta in the front right here. Well, you see we have two things on the top over tangent theta, so we can just do this over that, and that will give us tangent theta, and that's tangent to the first power, right? This over that. Next, we have 1 over tangent theta. 1 over tangent theta is the same as saying cotangent, which is just the same as saying cosine theta over sine theta. And then, of course, put on the d theta right here. So again, 1 over tangent theta is just cotangent, which is cosine over sine, and that's what we have. Okay, here is the deal. I'm going to multiply this in, and we see that the first part is actually nice because we can integrate secant theta times tangent theta with ease because the answer is just secant theta. But when we multiply this and that, well, we actually have to recognize that secant theta is the same as 1 over cosine theta. So when we multiply this and that, the cosine theta will cancel out. In fact, we just end up with plus 1 over sine theta, because again, they cancel out. And I'm just going to replace this with what? Cosecant theta. Yes. So this is cosecant theta, like so. D theta, like this. And then perhaps I'll put on the... A lot of people really want me to put a parentheses right after the integration sign before the d whatever. Sometimes I do, sometimes I don't. Why do I do it? Technically I should, but why don't I do it? I really think it's clear. So anyway, I don't really mind. But anyway, this is pretty much the prep work that we'll be doing, right? And now we can integrate this pretty easily because that's just secant theta, and we are done. But for this, well, the integral of cosecant theta, I will be using this answer, namely negative ln absolute value cosecant theta plus cotangent theta. All right, so this gives us that. You guys can check out other video for this if you guys need to. Okay, now the rest of the work is just go back to the x world. So we are going to refer back to that. So we're looking at tangent theta is equal to x, which is the same as x over 1. Draw the right triangle, put the angle here. X is the opposite, 1 is the adjacent. Hypotenuse is square root of this guy plus that guy, and both of them to the second power individually, like so. With this, we can figure that out. Check this out. Here we have secant theta. Secant is hypotenuse over adjacent. So we just have that. So that's the first part. Square root of 1 plus x squared. And we are done for that. Next, we will have the minus. And perhaps I'll change this to, yeah, it's okay. And then we have minus ln absolute value. And for the cosecant theta, cosecant is the reciprocal of sine, and cosecant is just hypotenuse over opposite. So this over that. So I will put down square root of 1 plus x squared over x. Lastly, we add cotangent, which is just adjacent over opposite, which is just 1 over x. And again, you can put them together, but it's okay. So that's all. Put down the plus c, and I think this right here go with that. So I think this is pretty clear. Okay, so yeah, this right here is a pretty hard one. So maybe you want to practice this again. And I think the best way is you just write this down again on a sheet of paper, and then try to see if you can redo everything by yourself or not. Don't look at any notes. And if you can really do it, that means you are getting it, and you will build out the confidence when you are able to do that. And that's what you really need in order to be successful in Cal 2. And of course, if you get stuck, then just take a look at what we did again, and then just try to practice on your own. Yeah. So for number 4, we have we have the integral of 1 over 9 plus x squared, and then raised to the 3 over 2 power. So remember, the over 2 power is the same as square root. So we are still kind of in this situation. But the main part is, pay attention to that we have 2 terms and we're adding, and this is the sum of 2 squares. Then we use the tangent substitution. Right here we see that 9 is the same as 3 squared, so a is equal to 3. And let's begin. Let x equal 3 times tangent theta. And then differentiate both sides, we get dx that's equal to 3 secant squared theta d theta. Alright, so this right here is going to be the integral 1 over parentheses, we have 9, and then plus. For this x right here, we'll just look at that as 3 tangent theta, and then we square that. And on the very outside here, we will have to raise this to the 3 over 2 power. And then for the dx, we will write down 3 times secant squared theta d theta. Alright, so we have this integral in the theta world. And now, as usual, let's fix this part. Inside out. This is 9, and this is also 9. We can factor that out. So we're looking at 9 times 1 plus tangent squared theta. Well, this right here is secant squared theta, so we are really looking at 9 times secant squared theta. This time, this is not just a square root. It's 3 over 2 power, right? So what you can do is, you can make the over 2 power into a square root. But don't forget to also raise the other part to be the third power. So right here, we take the square root, and then we take the rest to the third power. And now, square root of 9 is 3, and then square root of that is just secant to the first power, and then theta. And then we have to raise this to the third power. Yeah. And then this right here is 27. And here we have secant to the third power theta. Whew. Oh my god. That's what we have. Pretty cool, huh? Alright. Here is the cancellation part. It's actually better than number 3 in my opinion. Check this out. 3 and 27 can be reduced. So we have a 9 on the denominator. And you see that here we have secant squared, and this is secant to the third power. So we can cancel 2 of them out. So now this becomes the first power. So let's see what we really have. We have 1 over 9. And let me just put that down all the way in the front of the integral. And then we have the integral 1 over secant theta. Secant is 1 over cosine. 1 over secant is the same as just cosine. So the inside here is actually just cosine theta. Yep. So I told you this right here, it's actually easier than the other one. So that's what we have. Of course, to integrate this, we'll just do 1 over 9, and the integral of cosine is positive sine. Alright, and then at the end, we just have to go back to the x world. Take a look right here. We know x is equal to 3 times tangent theta. So that means tangent theta is equal to x over 3. Draw a right triangle real quick. Right angle here. Angle theta here, this is the opposite. This is the adjacent. And the hypotenuse is, open the square root, and we do this thing square. Actually, yeah, this thing square because the 9 goes first. 3 squared plus this thing squared, x squared, like so. So ladies and gentlemen, sine is the following. We still have the 1 over 9 in the front, but for sine, it's just opposite over hypotenuse. So we are looking at x over square root of 9 plus x squared. Yeah, like this. And perhaps at the very end, I'm just going to put x over 9 times the square root of 9 plus x squared all together right here. And then, of course, we're all done. Put down the plus c. This is it. Right? So, hopefully this video helps. And if you guys need more help with calculus, check out my other videos. Subscribe to my channel. And as always,